Continuing with the interesting effects of refraction of light in the atmosphere, there's a very usual thing which all of us would have seen, especially if we go for something like camping, and suppose you have something like a fire burning outside. So something very interesting happens, and we are looking at what that thing. So it's a case of atmospheric refraction, and suppose there's a something like a considerable fire going on at a particular place, and you can see that it's outside. That means the area which is burning is surrounded by air, and actually you can something like classify or differentiate that air surrounding the flame into three different areas. That is, the first area is that air which is quite very near and also in contact with the fire will be obviously very hot. As you go up, it will be lesser hot, and as you go up more and more away from the fire, naturally the air will become more and more cooler. It's obvious. Now this difference in temperature of the air which is in contact with the fire has an interesting effect when you see objects which are near this fireplace. So that's what we are looking at. So the physics is that hot air means that obviously the air molecules are something like fast, the intermolecular space is more, which means that we are dealing with a lesser density, which obviously indicates and leads to lesser refractive index. So at the second position you can see that it's not that hot, which means that it's more denser than the hot air, which means that the refractive index will be a little higher. And if you're far away from that area where the fire is going on, naturally it will be cooler air, which means that it will be dense air, which means that it will be, that area will be having a higher refraction. So if you look at the whole thing, I mean, so if this is the fire, you are seeing something like different refractive indices. So different regions of the air having different refractive. I can call it something like R1. If I call it R1, R2, R3, R1 is nearer the fire, R2 is further away, and R3 is very much away from the fire. You can see that R1 is actually lesser than R2, and R2 is lesser than R3. So you can, which basically means that more cooler the air, more the air would be more denser, which means that the refractive index would be higher. Now this difference of refractive index, along with the fact that the air near the hot place, I mean the air near the fire is not remaining stationary, that is, there's something like movement of air, causes a very interesting effect. So not the point, the air is now stationary. So you have the fire. So you have the fire going on. Suppose you place an object over here. So suppose an object is here. When you look at the object, you may see like the object is something like not stationary. Maybe sometime you may see that it's at another position. I will call it O dash. A little later it may be something like to something like a left of the actual position, O dash dash. So you'll be seeing something like the object something like wavering, some kind of a wavering effect. That is not stationary. This is because of the hot air, and also because that air is not stationary. So what I mean is that the apparent position of your object seen through the hot air fluctuates, it changes. This wavering effect obviously is due to atmospheric refraction, and more than that, also note that there are different, the whole area has, because of the difference in the heated air, has different refractive indices, and also because of the movement of air, the light is getting bent in different manner. So that's the reason why an object which is quite near a burning flame, when you look at it, you see something like a wavering effect. The object seems to something like shift its position. So that's the wavering effect. And this property is called atmospheric refraction because it's a refraction of light by the Earth's atmosphere. Thank you.